Welcome back. This is the first video in our coverage of Chapter 5, which talks about iteration, otherwise known as looping, or the ability to do things over and over and over again in our programs. So here's the outline of what we'll cover in this chapter. First of all, in this video, we're going to go through the motivation and overview as to why we actually need loops in the first place and what they do for us. Following that, our next video will talk about one of our pre-test loops, the while loop. Then there will be an example. Then we'll look at our second pre-test loop, the for loop, and do another video for another example. And finally, we'll end up with a discussion of the post-test loop in processing, which is called the do-while loop, and also a discussion of nesting loops, where we have one loop inside another. And then the capstone, so to speak, for the whole chapter will be an example that uses nested loops to apply an image filter. So let's begin to talk about why we need to have loops in the first place. So suppose that we have this situation. We want to draw in processing a target, a bullseye. Well, we could do that using 6 lines of code in processing. We'd have a line to set the fill color to white and then to draw a large circle. And then we're going to draw a smaller circle on top of it. So we would use a fill statement to set the color to red, then draw that circle. And then finally we'll draw a smaller yet circle on top of the other two. So we'll fill to white and then draw the ellipse. So fill, draw the large circle. Fill red, draw the medium circle. Fill white, draw the small circle. 6 lines of code to draw one target. That's not too bad. But what if I want to draw 4 targets? Then I would need 6 lines for the leftmost target, 6 lines for the second target, 6 lines for the third, and 6 lines for the fourth. So I'd have a total of 24 lines of code I'd need to draw those circles, those targets. And if I had 100 bullseye targets I had to draw, that would be 600 lines of code. And that gets a little bit unwieldy. But it could be even worse. So suppose that I have a game like this. And I'll show you an example here in a second, but the basic idea is that when it starts, it's going to begin drawing targets all over the screen, and I have to try to click on them to make them go away. Okay? So let's take a look at how that might work. We'll execute the program here. And once we start, it begins drawing all these different targets. Okay? So notice how the program, as it's written, really has no way of knowing in advance how many circles to draw, because it depends on how quickly I click the targets to make them go away. The faster I am, the fewer targets it has to clear, but if I'm slow, then it has to draw more targets. Okay? So there would be no way to write a program to do that, given what you know so far, because you don't know how many of those targets you need to draw. So that's where iteration or looping comes in. We'll use a structure that repeats a series of blocks, or a block of code rather, a series of lines of code over and over and over again. And in the case of this targets example, the code might be used to draw individual bullseye targets. Okay? So, here's where we are in our process of learning programming in processing. Any problem that can be solved with a computer can be solved as long as you know how to do 3 things in your programming language. You have to execute steps in sequence. Okay, we learned that in the first 3 chapters of the text. You need to be able to do selection that is, to choose to do one thing or another based on some condition at runtime, and we learned how to do that in Chapter 4. And then finally, we need to learn how to do things more than one time or iterate them. So with those three flows of control, any problem can be solved. Okay? So iteration is very important. Without it, there are certain problems that we just can't solve. Like we couldn't make that targets game that I just showed you. Okay? All right. Well, the processing programming language actually gives us several options of loops or iteration structures. You don't have to use them all. Really, you could get away with just one. But with practice, we'll be able to tell which one to use for a particular problem. And some are more appropriate to certain situations than others. So it's a good idea to learn all of them, and then you'll be able to choose the correct one when you need it. All of the loops that we're going to cover are governed by a Boolean control expression. So just like our if statements in Chapter 4 were governed by a Boolean control expression, so our loops are also governed by a Boolean control expression. So hopefully what you learned in Chapter 4 stuck, because you'll be able to apply that in this chapter as well. Alright, before we continue in the next video learning about the while loop, here's a quick warning. Don't lather, rinse, and repeat forever. Okay? If you caught the joke in the chapter, or if you've ever read the back of a shampoo bottle, you notice that the directions say lather, rinse, repeat. Well, if you follow those to the letter, you'd still be in the shower because it doesn't tell you when to stop. So we have to make sure that in our loops, in our iteration structures that we use, that something inside the body of the loop changes the value of that Boolean control expression. In other words, it has to sometime eventually become false so that we'll get out of the loop. If we don't, what happens is called an infinite loop, and that's a loop that goes on forever, and generally speaking, that's a bad thing. So we have to make sure that our program inside a loop changes the value of the control expression so that it can sometime become false, so the loop will finish. Okay, in our next video, we're going to go ahead and start talking about our first loop that we'll look at, which is the pretest loop known as the while loop. So, see you then.